3. Okay, without worrying about order, so we say basically you can select A and U, A and E, U and E. So those are the 3 ways in which you can select 2 vowels out of the 3. So those 3 consonant. Now there are how many consonants? 5. From 5, we have to select 3. So
Sir, your mic is off, sir.
sorry, ma. I don't know why it suddenly it goes off automatically. Okay. So please tell me, if it happens once again. Okay. So I do not know. There's something is wrong. Okay. Um, so I was saying that the number of ways to select 2 vowels and 3 consonants is 3 into 10, which is 30. So
Sir?
now each combination we have to.
Sir?
Yeah.
The screen isn't visible either.
What? Can you repeat, Akshaya?
The screen is not visible, sir.
Okay. So each of the combinations now can be shuffled, okay, in how many ways? So the 30 ways in which we can select 5 letters, okay. So once we have selected 5 letters, we have to form a 5-letter word out of that. So in how many ways we can do that? Am I audible? Hello?
Yes, sir.
Okay, okay. So each of the above combination can be arranged in how many ways? There are 5 letters, okay, so they can be shuffled in 5p5, which is 5 factorial ways. 5 factorial is 120. So there are 30 combinations, and each combination can be arranged in 120 ways. So therefore, total number of arrangements or total number of words is 30 times 120. Okay, so this is a common problem that involves both permutation and combination. Okay. Is that clear? Uh, Now everything is working fine. The video, audio, and all that.
Yes, sir.
Good, good, good. Okay. So let's look at the next problem. I hope you are all clear about the first problem, right? Any doubt?
No, sir.
Okay. Now next question. How many words, again, with or without meaning, can be formed using all the letters of the word equation at a time, so that the vowels and consonants occur together? Okay. So here vowels and consonants need to occur together. So all the vowels as one group, all the consonants as one group. So here you see how many vowels are there, how many consonants are there. That is what the first step. Number of vowels in equation. E, A, I, O. Right? Number of vowels. 4. Number of consonants. E is Q, right? U, A, I, O. E, U, A, I, O. It has got all the vowels. Okay, A, E, I, O, U. Okay, but all ones. So number of consonants is Q, T, N. So that is also, nothing is repeating. Q, T, N. Now the problem is, now this whole thing should appear as one group, and this whole thing should appear as one group. Okay, so but within this can be shuffled in whatever number of ways that we can, and similarly within the group of consonants this can also be shuffled. Okay, so the vowels group that can be shuffled in how many ways? Since there are 5 vowels, so they can be arranged in 5 factorial ways. Similarly, consonants, 3 consonants are there, they can be arranged in 3 factorial ways, which is 6. Okay, so we have got 120 arrangements of vowels and 6 arrangements of consonants. And the consonants and vowels, these 2 groups, how can they be arranged? We can put all the vowels first and then all the consonants, or we can put all the consonants first and then all the vowels. So therefore the total number of words is there are 120 arrangements of this vowel group, then 6 arrangements of the consonants group, and then 2 arrangements of the vowels and consonant groups, like putting the vowel first or consonant first. So this is your total number of words. So some of the problems, similar problems, I don't want to keep doing all the problems. So if you think that you can solve any problem, I would like to skip it and move on, so that you can take it as your exercise. Okay. the problem number 3 is a committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can it be done when the committee consists of exactly 3 girls, at least 3 girls, at most 3 girls? Do you think you can do this? Akshaya?
Yes, sir.
And what about the others? Sweets, cakes, service? No. Okay. What is the name of it? Sweets, cakes? I forgot.
Sita, sir.
Sita. Hi, Sita. Can you do this? And Suman? Okay. So let me do this. Some problems, I want you to try, okay, and take it as homework and try it, okay. So, but this problem, let me do. So there are 7 people need to be formed, put in the committee, okay. There are 9 boys and 4 girls. Now, when the committee has exactly 3 girls, means there has to be exactly 3 girls and 4 boys, because totally there need to be 7 people, right? So how many boys need to be there? So this is the only way we can do the form the committee with 4 boys and 3 girls. So now how many ways we can select 4 boys from 9? 9C4, and 3 girls from 4 is 4C3. So this is what is the total number of combinations in which we can pick up the 4 boys and 3 girls. So this is your answer, exactly 3 girls. 9C4 is how much? 9 into 7 is 9876 divided by 4 factorial into this is 4. This is just 4 because 4C3 is equal to 4C1, so it is just 4. So this gets cancelled. This 1, 2, 3 gets cancelled against 6. So your answer is 9 into 8 into 7, 72 into 7 is 504. Second one, at least 3 girls. At least 3 girls means how many girls and how many boys? What are the options available to us?
3 girls or about, sir.
Okay, so the first one that we did, 4 boys, 3 girls is 1. And the other option is?
3 boys, 4 girls.
Correct. 3 boys, 4 girls. So this we already calculated. 4 boys and 3 girls. We already calculated. In 504 ways we can do this. Form the committee. So, but similarly for 3 boys and 4 girls, how many ways can we do? So this means picking up 3 boys from 9. That is 9C3. Yeah, into 4C4. 4C4 means you have to choose all the 4 girls, which is 1. So this then the number is going to be 9C3, which is 9 into 8 into 7 divided by 3 factorial. Into this 4C4 is 1. So from 4 girls, we have to select 4 girls. Means only one way we can do that. So this one, 3, 2, 4. So 3 into 4 into 7, 12 into 7, 84, right? So here we have 4 boys and 3 girls in 504 ways, 3 boys and 4 girls in 84 ways.
அல்ல எனக்கு அவரை பார்த்தோன்னே உங்களை பார்த்தோன்னே எனக்கு ஒரு அபிப்பிராயம் அதே மாதிரி நான் சுமார் பார்த்தோன்னு ஒரு அபிப்பிராயம் முதல்ல அதுக்கப்புறம் நம்ம ரொம்ப க்ளோஸ் ஆகிருக்கு ஒரு 4 மாதம்.
So how many total? 504. At least number of ways.
பேசணும்னா கொஞ்சம் யாரும் எல்லார்கிட்டையும் பேச முடியாது இல்லையா? ஆமா அவர் வந்து ஆமா அவர்
So 504 plus 84. Okay, the third one, at most 4 girls. At most 3. At most 3 girls. So this we can do like 7 boys, okay, and no girls. 6 boys, 1 girl. Up to 3 girls we can take. Means all these options. 5 boys. So beyond that, 3 boys and 4 girls, that combination is not allowed. So same formula, similar way, we can calculate each of these combinations and add up. That is one way. The other way is how many ways in which we can select the total combinations of forming the committee. Forget about boys and girls. Totally there are how many people? 13 people are there. 4 boys and 7 girls. Out of which 7 need to be selected, right? So without considering boys or girls, we can total number of combinations that we can make is 13C7. Since we can have only up to 3 girls, 0, 1, 2, 3, so we have to only exclude the combinations in which there will be 4 girls. Okay, so exclude combinations that have 4 girls. But this we already calculated. 4 girls, how many combinations are there with 4 girls? This is 84. So either we can add up these 4, calculate each, this is what 7 boys means out of 9 boys. So it will be 9C7. Okay, so this will be 9C6 into 4C1. It will be 9C5 into. So we can do all these calculations and add up. Okay, or we have simply calculate 13C7 and subtract this 84. You will get the same answer. Okay, so this is easier, right? 13C7 minus 84.
எனக்கு ஒரு டவுட் இருக்குது அவங்க சொன்னதெல்லாம் வச்சு பார்த்தா டவுட் இருக்கு ஐ மே பி ராங் ஆல்சோ அதனால நீங்க மறுபடியும் கேட்டா அவங்க யாரு என்ன
So let me just calculate it.
நீயே சொல்லுங்க அப்புறம் அந்த அவங்க நம்பர் கொடுங்க அப்புறம்
13C7 is same as 13C6. Okay, so I'm going to put 13C6. It's a tedious calculation. 6 factorial, I know it is 720. Okay. So I see that 10 into 9 into 8 is 720. Okay, 8 9s are 72, so I can simply cut it off. So simply you have to multiply 13 and 12, and 13 12 we know is 156. So 156 into 11. So 11 6 are 66. Okay, or 11 5 6.
I don't know. அது சொல்லுச்சு அது என்ன அது அது அதான் இல்லை மனசுல வச்சுக்கங்க அப்புறம் யாரு என்ன அப்படின்னு அப்படி கேட்டு வச்சுக்கங்க இவங்க இவங்க நீங்களா கூப்பிட வேண்டாம் அவங்களா கூப்பிட்டா இவங்க என்ன எஸ் சொல்லல.
So you get 1632. But if you try to calculate this 9C7, all those combinations listed above, you will get the same answer. So I leave it to you to calculate that in the other manner. So you can do the problem in multiple ways. Okay, so you can cross check that that both the methods give the same answer. Okay, let's I hope you are following, right, what I am doing, right? Akshaya, Sarvesh, and
Yes, sir.
yeah, Sita, right? Sita, are you there?
Yes, sir.
Okay, so hope you are following, right?
Yes, sir.
Good. So now let's look at this problem, fourth problem. I want you to do it now. Okay, if the different permutations of all the letters of the word examination are listed in the dictionary, how many words are there in this list before the first word starting with E? Okay, so I want you to try this problem. Okay, or this is looking slightly different from whatever you have seen. So let me just help in this. See how many letters words are there before the first word starting with E. So you see that the letters that are there are the one with the earliest in the alphabet, that is A. Okay, so you will first have all the words starting with A. Okay, and then you will have all the words starting with E, because after that E only, because A, B, C, D are not there. So after completing all the words with A, so you are going to start with letters starting with E. So that means basically how many words are there starting with A. So that is what you have to do. Okay, so first letter we have to put A. Okay, the remaining letters, in how many arrangements we can do. Now all of them we have to exhaust before going to starting with E, right? So if you take one A out, so what is remaining? Now we have to write down. So how many A's are there? Totally 2, right? E1, X1, A potential, M1,
I2, sir.
I2, right?
F1.
N2, T, so this is your total configuration, you can see, of this word examination. We'll cross check 1 2 3 4 5 6 7 8 9 10 11, right? 11 letters are there, and we see that there are 2 A's, 1 E, 1 X, 1 M, 2 I's, 2 N's, 1 T, 1, so 1 O. So 1, 2, 4, 6, 7, 8, 9, 11. So it is matching. So this is your total configuration of the word examination. So now we have put 1A here. So what remains? What remains is, so this becomes 1. So this is what remains, 1A, then all these things, 1E, 1X, etc. So in how many ways we can arrange this? So that is your question now. So problem simplifies to as simple as this. So how many words we can arrange this? Examination minus 1A.
10 factorial, sir.
So 10 factorial, very good. 10 factorial ways in which you can arrange because there are 10 letters. But there are repetitions, right? N is appearing 2 times, I is appearing 2 times. So what should you do for that?
We can consider it as I1 or I2, or we can just consider it as the same letter or something like that, sir.
Actually, I didn't hear properly. Can you repeat? Then repeat it slowly.
In our book, there is a sum that's given where they take 2 same letters as, let's say, I1 and I2, something like that.
Exactly. So what should we do?
So we make the 2 N's, N1 and N2, and I1 and I2, sir.
See, 10 factorial is the total number of arrangements, but the combinations with I1 and I2, we have to count it as 1 only, right? There's 2 combinations, we have to count as 1. So therefore, we divide it by 2 factorial because I is appearing 2 times. So N is appearing 2 times. So again, we divide it by 2 factorial. Okay. Because there will be one word with I1 here, I2 here, another word with I2 here, I1 here, but they are same. If this is also I, this is also I, right? So if you are counting I, as just letter I, so we will count these two as same. So, but in our way of 10 factorial, we have counted it as 2 times. So that is why we are dividing by 2. Same logic for N also. So N is there 2 times. So we divide by 2 factorial. If there is some word that appears 3 times, so then we will divide it by 3 factorial and so on. Okay. So here, since there is one letter appearing two times, 2 words appearing 2 times, so we divide it by 2 factorial twice. So this is your answer, 10 factorial divided by 2 factorial, 2 factorial. Okay. How many 6-digit numbers can be formed from the digit 0, 1, 3, 5, 7, 9, which are divisible by 10 and no digit is repeated? So I want you to do this problem, okay? So, but not now, but do it later and let me know and send your answer to me, okay? Because now we can do some other problem, that is why, okay? So this is a very simple problem. We've seen similar problems, right? How many 6-digit numbers can be formed from the digit 0, 1, 2, 3, 5, 7, 9? Divisible by 10 means, okay, last digit has to be 0, right? The rest of the digits we can shuffle. So question is how many ways we can do that. And similarly, this problem 8 is also something that we have done before. Similar problem we have done. So English alphabet has got 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So it's a question of how many ways we can pick up 2 vowels and how many ways we can pick up 2 consonants and how we can arrange them to form words. You remember we did a similar problem in the beginning. So look at that problem, think about it, and work on these 2 problems. Okay? So that we can move on to some newer problems. So can you try, all of you?
Yes, sir.
Akshaya, good. And Sita?
Yes.
Yeah, please try. Okay. And Sarvesh? Okay. So please try afterwards. Okay. After the end of the class, please try and let me know. Okay. Now let's go to, these are some problems from the past IIT paper, JEE. Now they are slightly complicated, but not very difficult. We can still do them from same concepts only, right? The number of words with or without meaning that can be formed from the word mathematics, where C and S do not come together. Okay. How can you do this? I'll give you a clue. Can somebody think of any way before I go to give clues? Okay. See, the total number of words. Calculate the total number of words. Number of words where C, S do not come together. Equal to total number of words.
Yes, sir. Total number of words 12, sir.
1 minute. Total number of words minus number of words where C, S come together. It's a combination of two problems. So how many total number of words we can form? And how many words can be found where C and S come together? These two are some problems that we have, similar problems we have seen before. Okay, now first tell me total number of words, how many can be formed? Mathematics. 11. 1 minute. How many M's are there?
11.
2, sir.
1. You have to list like that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters are there. Okay. So now M 2 times. Okay. Then A, how many?
2, sir.
2. T?
2 times, sir.
2.
2. H?
1.
Once.
1.
1. M we already counted. A also we have counted. T also we have counted. I?
Yes, sir.
I, sir, 1. C, 1. Yes, 1.
Okay. So does it match? 2 plus 2 plus 2, 6, 7, 8, 9, 10, 11. 11 letters. So now this is a word that comprises of 11 letters, out of which M is appearing 2 times, A 2 times, T 2 times. So how many number of words can be formed?
11 factorial, sir.
11 factorial. Then what about this repeating? What should we do for the
11
repeating?
factorial divided by 2 factorial into 2 factorial into 2 factorial.
Yeah, that's right. Because M is appearing 2 times, we treat it as M1 and M2. So the different arrangements, what is counted as 2, we should actually count it as 1. Therefore, we divide it by 2 factorial. Similarly, another 2 factorial for A and for T also. So total number of words, the first problem is right. So now we will see C and S come together, because we have rephrased the problem. Since two C do not come together, we have rewritten as total minus C and S come together. So how many combinations are there in which C and S come together?
If we take C and S as one unit,
We have to take C and S as just one letter, right? If we take C and S as one letter, then how many words are there? That means instead of 11 letters, there are only like 10 letters. So this
Yes,
value
sir.
plus C and S together we count as 1. So 10 factorial divided by, again this 2, 2, 2 are there, right? Again M is there 2 times, A is there 2 times, T is there 2 times.
Sir, what if we interchange C and S?
Huh. Sorry?
What if we interchange C and S, sir?
Yes, exactly. So what should we do for that? Tell me.
Multiply it by 2 factorial?
Multiply by 2, correct. Because, so here in all these combinations C and S come together, but we count CS and SC as two different words. Okay, so that is why we have to multiply by another 2 factorial, which is the shuffling of the CS itself, the 2 letters. So this is what is your total number of words in which C and S come together. Okay, so one of the 2 factorial get cancelled out, and this is 10 factorial divided by 2 into 2, 4. And this is your 11 factorial divided by 2 into 2 into 2, 8. But now, therefore, your answer is, required answer is total minus this, right? 11 factorial by 8 minus 10 factorial by 4. So how can we bring it to one of those forms? So you can see that everywhere 10 factorial is appearing. So what should we do?
11 into 10 factorial.
So we take out the first one, you write as 11 into 10 factorial divided by 8 minus 10 factorial divided by 4. Okay. Or we can say 2 into 10 factorial divided by 8, just to keep it simple. Okay. So now we take this 10 factorial divided by 8 out. What happens? Ten factorial into 9 by 8 is what you get. So which option is giving 10 factorial into 9 by 8? There is an option, right? Option 1. Okay. Is that clear to all?
Yes, sir.
Okay. Sita?
Yeah, sir. Yes, sir.
Good, good. Sarvesh, are you okay? Are you following? Okay. Let's look at the next problem. If the number of all 4-letter words with 2 vowels and 2 consonants from the word universe is n, then n minus 500 is. So we have to count all the 4-letter words with 2 vowels and 2 consonants from the word universe. So how do we do this? So universe. So how many U's are there? 1. N, I am writing on this side. This consonant on this side and vowel on this side. Okay. I1, V1, E2, Is it matching? Totally how many letters? 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 4, 5, 6, 7, 8. There are 4 consonants and 4 vowels, but 4 vowels, there is a repetition. E is appearing 2 times. So that is the only tricky part here. Okay. Now we have to pick up 2 vowels and 2 consonants. In how many ways we can pick two vowels here? It's a little tricky because either we can pick up 2 E's or we can pick up 1 E and then along with that 1 I or U and I. So when we pick up 1 E, we can pick up the remaining as E and remaining the 3 words are there, right? Three letters are there. Because there is another E and I and U. 1 minute. We pick up. We are not having 2 E's. Okay, so those combinations are UI, UE, and IE. So there are 3 combinations. I'll write them: UI, UE, IE. Okay. So this I'll write as EE to be. So we can select the vowels in these 4 ways only. So in one combination there is going to be 2 E's. Other there are 3 combinations in which it's going to be UI, UE, and IE. So vowels, consonants, there are 4 consonants. How many ways we can pick up 2? 4 C2. That is 6. There are things like N, V, N, R, N, S, V, R. Okay. So these are the 6 combinations. Why we have to separate this EE and this out is the arrangement, counting of arrangements will differ. We cannot put them all together. Like there are 4 ways in which we can pick up 2 vowels. Therefore, we can say 4 into 6. Like that we cannot do, because here the arrangement, number of arrangements, if E is repeating, the formula is different, and when there is no repetition, the formula is different. So you have to count this case separately and this case separately. Okay. Suppose in this combination EE and the 6 combinations of this, okay, there are only 1 into 6. There are 6 combinations, but how many permutations are there? The permutation includes the 2 E's and 2 consonants. That means here 4 factorial divided by 2 factorial. Whereas if it is UI, UE, IE and 2 consonants, here there are 3 ways to select 2 vowels and 6 ways to select 2 consonants, so 18 combinations. And for each of these combinations, because here the letters are all distinct, there is no repetition, therefore we can shuffle in 4 factorial ways. So here the ways of permuting is, the formula is different, and here the way to compute the permutation is different. That is why we need to keep these 2 as 2 separate cases. So in this there are 6 combinations and each one has got 4 factorial divided by 2 factorial. In this 18 combinations, but each combination has got 4 factorial arrangements. Therefore the total is 6 into 4 factorial by 2 factorial. (18 into 4 factorial). So this is 72 plus this is 432, right? 18 4 so 72 7 504. So you have to be careful when you are forming the combinations and then forming the permutations. When you form the combinations, if there are repetitions, you have to consider them separately. So how many combinations in which there is repetition, how many combinations in which there is no repetition, you have to treat them separately, because the arrangement count, the formula is going to be different in these two scenarios. So that is why we have done like this. So there are, in this way we can totally do 504 arrangements. So the n is equal to 504. So n minus 500 will be 4. So okay. So hope you all followed. This problem is a little hard. But these are the kind of problems. It's not very difficult. You know, we have two different scenarios, and the reason why we need to treat these two scenarios also I explained. Right? Hope you all followed, right? Shall we move on? Or if you have any questions, please feel free to ask me. You did not follow any step in this. Akshaya?
Yes, sir.
Okay. You are okay? You have followed?
Yes, sir.
Good. And Sita, Sarvesh?
Yes, sir.
Sarvesh? Good. Very good. So let's go to another problem. I think we'll have time to do this problem, but the remaining problems again I'm going to give it to you as homework. There are a couple of problems. This problem is very interesting. The number of ways to distribute 20 chocolate among 3 students such that each student will get at least 1 chocolate. So here the 20 chocolates are similar, identical chocolates. So we cannot, this is not a combination like 20C3 or it's not like that. Because 20 chocolates are there, we have to give it to 3 students. Okay, so it's a slightly different way of counting distribution. Okay, so how do we do this? See, let's say put those chocolates here. They're all similar, right? So let's put these chocolates like this. Identical chocolates, 20 chocolates. Now we have to distribute it to 3 students so that each student will get at least 1 chocolate. There are how many gaps are there in between these chocolates? 19 gaps are there, right? So in these 19 places, you pick any 2, okay, and draw a line. Okay, this means first student gets 4 chocolates, second student gets 7 chocolates, third student gets the remaining. So like this, we can draw the line in any two of the blanks. Okay, so each one will give you a combination of, how we can distribute. Okay, so basically, so there are 19 gaps and two lines you have to draw. So out from the 19 paces. So basically that means 19C2 is the number of ways in which we can do this distribution. Okay. Actually, this question can be asked in different ways. Like instead of saying each student will get at least one chocolate, you can get a question like that condition is not there, or each student will get at least 2 chocolates. So different ways in which this question can be asked. So you need to know, a general way of how to solve this. Okay, so that way also I'm going to tell you. This is one logical way, this 19C2, but there is another way which can handle even different scenarios. Okay, that is, so when we have to each student will get at least one chocolate means he can get one chocolate or 2 chocolates, 3 chocolates, or 20 chocolates. Okay, up to 20. You write it like this: x plus x squared plus x cubed whole to the power of 3. There are 3 students. Okay, so that means, so you pick up 1 from here. That means 3 means it is going to appear 3 times, right? When you multiply this, what will happen is, so from here, one value will be taken. From the here, second one value will be taken, and third one value will be taken and multiplied, and then you will get, a big expression. In that, if we count the coefficient of x square 20, so that means all the combinations will come. So either it can be 1 plus 2 plus 17, or 3 plus 2 plus 15, and so on. All the combinations we will be able to count. It means basically we need to count the coefficient of x power 20. In this expansion. This உங்களுக்கு பைனாமியல் தியரம் நடத்திருப்பாங்கன்னு நினைக்கிறேன் இல்லையா? So there is a formula for this using binomial theorem. I'll come to that. So this we can write as x cube into 1 plus this is not 19. It can go indefinitely also, because it doesn't matter. We will only count, up to 20, right? So if it goes beyond 20, 21, 22 and all, we are only going to count the coefficient of x power 20, so it doesn't impact us. So this is a geometric series, right? We can see that this is a geometric series to infinity, 1 plus x square, so which simplifies to 1 minus x. Okay. So I am taking out this x cube. This thing I have written as 1 by 1 minus x whole power 3. Now, the coefficient of x power 20 in this expression is same as, we can, since we have x cube into something, we can take it out and say coefficient of x power 17. In this expansion, 1 minus x whole to the power of minus 3, because 1 by 1 minus x is 1 by 1 minus x to the power of minus 1. So we have a binomial expansion for this. So you would have seen binomial expansion for 1 minus x to the power of plus 3 plus 4. But there is also a binomial expansion for 1 minus x to the power of minus 3 and so on. Okay. So in that expansion, if we can get the coefficient of x power 17, that is the answer we need. Okay. Why I am proposing this method is because suppose they ask you, we have to distribute the chocolates so that students get, each student get odd number of chocolates. Then this will become, the square and all will go away, x plus x2 plus so on up to x power 19 in this expansion. So we use this method to solve many different other scenarios also. Okay. Whereas the first method I said only will work for this simple problem, but there are other complex scenarios. You can always use this particular approach. So I'll tell you the expansion is 1 minus x whole to the power of minus 3. It is 1 plus 3c1 into x plus 3, let us say 3c1 or 3. This is, instead of this will become, if it is 1 plus, the coefficient is positive, we will write a 3c2, whereas 3 into 2. So in this case, since it is negative, it will become 3 into 4 by 2 factorial. You see this expansion is there in your book, okay? So you can see that. And so on. Is equal to, so coefficient of x power 17, we'll write it in a different way. 1 plus, this is 3c1 plus, this you can see 4 into 3 by 2 factorial, right? 4c1, 4c2. So this is 5 into 4 into 3 by 3 factorial, 5c3. So you can see that it goes on like that, 6c4 into x power 4 and so on. So now you can see where that x power 17 will come. So x power 17 means coefficient of 17. I'll try to write it. When it is x power, this is 17. So this, the lower number will be 17, the upper number will be plus 2. So you see the pattern, right? So if you see like that. In the 17th term, this number would have become 16, this number would have become 17. So this is your coefficient of x power 17. So this is the answer that we want. Therefore, the number of ways is 19c17, which is same as 19c2. Okay. So this is a useful formula, that method, useful method that you can apply. Suppose they ask you, each student, this condition is not there, then what will happen is, there is a general formula for that. If, distribute 20 chocolates among 3 students without any condition, but there's at least one chocolate, that condition, suppose no condition is there,
கொஸ்டின் பேப்பர்ஸ்
then it
Very
will
அது
be.
நீ ஃபுல்லா நீட் பேஸ்டா இருந்தது. அது எங்களுக்கு நாங்க ஜேஇ சிலப்பட்டதை மட்டும் எடுத்துக்கிட்டோம். பட் நீட்டோட தான் இருக்காங்க சார். ஸோ அது என்ன பண்றதுன்னு தெரியல.
அப்படியே வைங்க.
கேட்டோம். ஸோ சார்
எங்க ஸ்டூடெண்ட்ஸ் இருக்காங்க. நீ ஈரோடு தானே, இல்லை நீங்க திருப்பூர் தானே?
திருப்பூர் தாங்க சார்.
N plus R
இல்ல நீங்க உங்ககிட்டயே வைங்க. உங்க வீட்லயே வந்து வாங்குற மாதிரி நான் பிளான் பண்ணிடுறேன். எங்க பசங்களை அனுப்பிச்சு வாங்கிக்க சொல்றேன்.
ஓகேங்க சார்.
சரியா?
ஓகேங்க சார்.
So N is the
அந்த மாஸ்டர் ஜி
total number of
நல்லா தெரியும்.
students.
அந்த
I
மாஸ்டர்
mean,
ஜி
the number of chocolates, and R is the number of people to which you are dividing. So in the formula, if n objects, identical objects, are to be divided among R people without any condition, it will be n plus R minus 1 C R minus 1.
கோயம்புத்தூர்ல இருந்து க்ளோஸ் பண்ணிட்டாங்க. ஆனா அது எல்லாம் தெரியும். என்னோட ரெண்டாவது பையன் இருக்காங்க. எனக்கு ரெண்டாவது பையன் அங்கதான் படிச்சான்.
Basically, using this formula, what we can do is,
அங்கதான் கோச்சிங்
since there are each student needs to get at least one chocolate, so you give away one chocolate each. So then there are only 17 chocolates to be divided among 3 students. Yeah, apply the general formula in that case. What will be 17 plus 3
குழந்தைக்கு வேணும், நான் வாங்கிக்கிறேன். அவங்கள வந்து வாங்கி சொல்றேன்.
C
ஓகேங்க சார்.
3 minus 1.
கண்டிப்பா.
So that is how you get 19C. So this general formula you should remember for division without any constraint. Suppose they tell you each student has to get at least 2 chocolates, you give away 2, 2, 2, okay?
Yes sir.
Or has to get at least 2 chocolates. So you give 2, 2, 2. Remaining 14 will be there, and you apply the general formula on that. So 14 chocolates to be divided among 3. So it will be 14 plus 3 minus 1 divided by C 3 minus 1. Okay. So this is a general scenario you need to learn to solve problems of this nature. Okay. So please go and look at the formula in your book for binomial expansion, like I said, no, with a negative exponent. Okay, and look at this problem carefully once again. Okay, so that you understand this type of problem, because it is a very commonly asked type of problem. So like I said, multiple ways are there in which the question can be asked, and you can apply the general formula if you know this approach. Okay, so the next 2 problems, I think time is also running out, and I also want to give some exercise to you. So I am sure you should be able to do this with whatever we have discussed so far today. Consider the word independence, the number of words such as all vowels are together. So, and again using the number 1, 2, 3 up to 7, total number of 7-digit number which does not contain these 2 strings, okay, without repetition. So I want you to try these 2 problems. Similarly, the 2 problems that we left out in the first group, right? Remaining we did only 2 problems we left out. So these 4 problems, I want you all to try and solve it, and please send it to me. Okay. So that is the way you really get confidence, and you then only you will grasp all the methods that are required. Okay. So please do that. And with this, I want to close the permutations and combinations. We will go on to the next topic, which is binomial theorem, from the next class. Okay. Any questions? Can you do these 4 problems, Akshaya?
Yes, sir.
Okay, you should do that. It's not very difficult. It's similar to whatever you have done. So please do that and send it to me. Okay. Sita?
Yes, sir.